Idem, welcome. You're listening to People, Planet, Food, conversations about the global food system that I hope are both a cause for optimism and a call to action. I'm Roger Robson-Williams, Chief Sustainability Officer here at Plant and Food Research. I'm interested in how to grow healthy, enjoyable and affordable food in ways that don't harm people or planet. In this podcast series, I'm talking to some of the inspiring people I've met about what needs to change if we're to have healthy people living on a healthy planet and eating healthy food. In this episode of People, Planet, Food, I'm delighted to be talking with Jack Donaldson. Jack leads business development at Mackwell & Co. And I think before introducing Jack, I need to say a little bit about the company he works for. So Mackwell & Co. is a team of engineers based in Ōtautahi, Christchurch on New Zealand's South Island, who are reimagining steam power for the 21st century. In their own words, they're at the cutting edge of low tech. And I'm really looking forward to this conversation with Jack, who formerly worked at Rocket Lab, and I think we'll hear a little bit more about that shortly, and also at the Climate Change Commission here in New Zealand. He now aims, in, again, his own words, to connect the biomass steam engine technology being developed at Mackwell with people who are seeking value in energy sovereignty, while offering an alternative narrative to mainstream renewable energy solutions in agriculture. So with that, welcome Jack.
Kia ora, Roger.
I think before we get started, it would be great if you could tell us a bit more about yourself and the journey you've been on that's landed you up in a workshop behind the airport at Christchurch.
Well, I first came across Mackwell when I was working for the Climate Change Commission. That was early last year. And I was on the energy and industry sector team as a senior analyst. And my colleagues from that time would probably laugh about this now, because I remember showing them a image, looked like something from Google Sketch, on a website that was a steam tractor. And it took some imagination to see how that might possibly, be of any assistance in solving some of our climate issues. But yes, basically I ended up, as I am now, working at Mackwell. And I suppose before the Climate Change Commission, my background was really in venture tech. So I was fortunate enough to work for a couple of now well-known names in New Zealand. First at Power by Proxy in Freeman's Bay in Auckland, and then spent more of my time at Rocket Lab as a risk engineer. So I see what I'm doing now as a nice synthesis of, I guess, those two areas of technology and climate action.
I don't think there'd be many conversations where aerospace technology and steam technology would be brought together. Can you tell us just a bit more about what you did at Rocket Lab?
Sure. There was a number of jobs I did while I was there. It was over a period of nearly 5 years. So when I joined, I was actually in a compliance role, more or less, and there was some amount of time I spent at the launch site doing operational work associated with that. So it was very exciting at the time, quite sort of edge of the seat stuff. But as I went through, I focused more and more on the engineering. There was also a greater need for risk engineering at a higher level. So basically, I would say that engineering is a discipline. You can look at different applications of technology and think that things are radically different, but at the end of the day, the principles behind it are always the same. And I certainly see a lot of value in what I learned at Rocket Lab, both in an purely engineering sense and also from a business point of view, as applying to the steam engines that we're developing at Mackwell, and really just having to, apply those skills in different ways to fit the purpose.
The engineering piece comes through very strongly, and I guess it sounds as though there's an interest in that kind of startup innovation kind of scene as well. But the climate change piece and really what Mackwell is trying to do also speak to an interest in sustainability. Could you tell me a bit more about that from your perspective?
Yeah, so sustainability, I'm a 93 baby, so I'm a millennial. I think it's probably true that it's the first generation that had certainly climate awareness in formal education. I remember that from high school. And so that's obviously a strong influence. But then, and this is talking more about myself, I guess, than either Rocket Lab or Macwell, but, following on from education at an early age, I certainly became interested in sustainability through, I guess, my own interests, particularly in the outdoors. And as an example, a couple of seasons ago, I was doing some walking around the Mount Aspiring Regional Park and came to a point where I was supposed to cross onto a glacier, and I could not because it had melted back that far. It was just an impasse. And I think you hear about that stuff a lot. It almost becomes cliche when you hear about it in the news, but seeing it up close and personal certainly can be quite confronting. And I think it's those experiences which drive me in my own life to try and make some change.
Thanks for sharing that. And I think your observation about the power of seeing things is really important, and a kind of a nice segue to ask you a bit more about the work that Macwell is doing, in the sense that it would be easy, and I confess perhaps to having done this a bit myself, to dismiss the concept of steam technology when I first kind of heard about it, but coming to the workshop and seeing the reality of what you're trying to do puts it in a very different perspective for me. So with that, could you just tell us a bit more what Macwell are actually doing, what you're aiming to achieve?
So Macwell are developing biomass-powered steam engines to enable energy sovereignty, and I can describe energy sovereignty a bit more later on perhaps, but just focusing on the steam engines to begin. It's really taking what is the original locomotive engine. They typically ran on coal, but sometimes wood as well, and seeing how that can become a carbon neutral engine for today, and that means returning to using it with wood or biomass of some sort. And in order to do that effectively, you really need to, I guess, address each of the individual aspects of the design that ended up in some way contributing to its demise 100 years ago. And so what we have now is something that looks fairly similar on the outside, but inside is really very different. And just to, I guess, go through in layman's terms, there's more or less 4 sections to it, which is the firebox where the fuel is introduced, a cyclonic combustion chamber, which is really for sort of completing the burn of the fuel and removing any of the particulate which used to just go straight through and out the stack. We've then got the heat exchanger, and it's a water tube design. And finally, what used to be called the smoke box and the funnel, which is actually sort of a series of injectors and drafting pipes to really encourage the airflow through the engine. So that's the overall design, and it's really getting towards the best way to convert biomass to energy in a way that's useful, so provide useful work, and that could be in shaft power, direct shaft power for motion, or driving machinery, generating electricity, or even just producing the heat that can be used in various applications.
So Jack, with all respect, haven't we been here before with traction engines?
Yeah, I get this question a lot, and there are 3 things that stand out to me. So firstly is that steam engines may be less common at a consumer scale today, but still steam technology is essential to many people's livelihoods. Most of the big power generation stations in the world use steam in some form. So it's really just about rethinking the scale and bringing it back to something that's a bit closer to us. The second is perspective. Many things that we see as modern, such as electric cars, they've been around for more than 100 years. So although we are able to create, seems like endless new forms of technology, the underpinning principles or the essential ideas, there's perhaps not as many new ones as you might think. And so at Macwell, we try and acknowledge the past to inform our future. And the third is innovation, because the fact that steam engines, or steam locomotives in particular, really went away, say, 100 years ago, just makes it more ripe for improvement. And we do that by looking at every aspect of it and seeing how it can be made fit for use today.
And before we come on to some of those issues of how it can be made more fit for use today, why would we even consider it today? What's different now?
Right. The key one, of course, is the awareness of climate change and really trying to find a technology that can perform in the way we need it to, but without the greenhouse gas emissions. And so I guess there's been a fairly long journey to get to the solution that we're working on right now. But essentially it's to use biomass at its point of source, which we know to be a carbon neutral technology. And that is preceded by having a way to transform the biomass into useful work. And external combustion engines, like steam locomotives, unlike diesel tractors, are at least one way to do that.
Yeah, okay, so we've got a kind of different contextual setting. We've got some historic technology that's worth revisiting. What aspects of that are you particularly confident you can improve?
The key one is energy return on investment. So it's a term that's not particularly well known, but certainly within some disciplines, such as transition engineering, it's well known. The easiest way to describe it is whatever energy source you're using, imagine the energy that's required to extract that or to make it available, and then deduct that from the energy that's in it as a chemical form, if it's biomass or liquid fossil fuel, then you end up with this net amount of energy at the end, which you can use. So in the case of biomass specifically, we'd like to be able to make use of the biomass at the point that you collect it and without any further processing as much as possible, so that you retain all of the energy that was locked into the biomass at its point of growth. And one thing that we sometimes like to say, half jokingly, but in all honesty, that it's a solar-powered tractor because it's using the energy in the biomass that the plant harvested from the sun while it was growing. And so in that way, it's not actually too dissimilar to using, for instance, a solar panel array to charge your electric tractor in terms of where the energy flows are going in and out.
Yeah, and so you have at the workshop, I've seen this, a very substantial locomotive steam engine, 300 horsepower, I think, but that is not, of immediate relevance to the food system, and this is a conversation about People, Planet, Food. So perhaps you could tell our listeners more about your more immediate plans and how they relate to the agricultural production.
Yeah, so I think that at a very high level, the comparison can be made between steam as a source of energy and food also as a source of energy for humans. So my partner, who's a foodie, would hate me for suggesting that food is fuel, but I think that that's exactly what I'm saying. And if you were to imagine a farm, they're basically a producer of food, but the inputs to the farm, and we're talking here from an energy systems perspective, which today is typically fossil fuels, fertilizer, things like this, they compete with the food that's output from a calorific point of view. So imagine now if you could turn that around and say, well, it's possible that having fossil fuel inputs, you actually get less energy out of the farm than you put in. That is possibly one definition of being unsustainable. So let's turn that around now and say if you could produce the energy needed to perform the farm work from just a small fraction of the land area, then, and I say that by using the biomass to fuel the machinery as an example, then that becomes a net energy producer. And really that's what we're trying to encourage with the technology, is a means to be able to do that. So I think that's the best way to imagine the link between the two.
Yeah, and I guess for me personally, the thing that I find really fascinating and it kind of has real potential is that the food system relies on a lot of machines, and we've been able to globally develop a much more productive food system because of the use of that kind of mechanical energy, and most of that at the moment comes from liquid fossil fuels, namely diesel. And it seems to me and I'd be interested in your views on this, but we could well be looking at a future where certainly the cost of that liquid energy goes up and its availability might become lower and more variable. So having a kind of plan B seems really sensible. Obviously, a kind of really conventional plan B that we hear a lot about at the moment is electrification, which again makes sense, particularly in a country like New Zealand with a high proportion of renewable energy in our grid and potential for example, farms to have their own solar distributed generation and so on. So how does your technology fit in with that?
There certainly is, a lot of electrification happening at this point, and I think that there are places that makes sense, but there are also places where perhaps it does not, and those are remote places, obviously anywhere that doesn't have easy or affordable access to the grid, and many of those places are farms. So we talk with people who, see, I guess, the negative side of this, where they have to really pay a lot for the grid connection, and maybe in some cases it's not even possible. So it's about providing options to suit their needs, and obviously if they don't have that but they do have the biomass available, then it would be great to make use of that. And I think there's also another part to this, which is just that the resilience of the food network at the moment, as you said before, it's probably tied to liquid fossil fuel. There's a possibility we move to a future where, not everything, but most things would be electrified. There'd still be some issue, I think, around the resilience of that system and still really having your eggs in one basket, so to speak. So it's just about being able to provide people with the option to do what works best for them.
Yeah, that certainly makes sense. And that issue of resilience is something that, in fact, when you visited my property, we talked a bit about. And I guess another dimension to it beyond, potential instability in the kind of electricity grid and access to that form of power is the maintenance and the ongoing kind of reliability of the technology that we use. And I know from what you've said that's quite an important part of the kind of Macwell ethos in the way you're designing these machines to be repairable and maintainable into the future. Could you say a little bit more about that?
Yes, yeah. So it's definitely a part of energy sovereignty and, as you said, the resilience. So we encourage the right to repair for the products that we will make, and I think it's important that for that to be a reality, people can actually make the repairs themselves, or at least within the community that they're in. So electronic goods would be one example, I think, of a market that's done amazingly well at reducing costs and really increasing availability to people, but invariably it's outside of the reality of most people, to actually conduct repairs and to be able to service that stuff themselves. So we're going back to more mechanical systems and things which we believe are still going to be able to be repaired for many years, and we actually like to say intergenerationally, using what is to hand and possibly going back to something which I think is has been a New Zealand value, which is to be able to fix things yourselves and to be self-sufficient in that manner. That
intergenerational perspective isn't something I've heard you mention before, and is really, really interesting. I've been doing a bit of thinking about the mindset that I have and the kind of short-term thinking that pervades my worldview, really. Could you say a little bit more about that? Just unpack that intergenerational dimension a bit more?
I think you're right that probably for most people in New Zealand now, it's just become a part of our day-to-day that things are fairly temporary and short-term thinking is maybe more typical. But if you were to look at human history, I don't believe that's the case. And certainly thinking about sustainability, what does that really mean? It's not something that necessarily has a quick fix, but if we want to invest in things now that have sustainable outcomes, then it really does mean being able to have tools and skills that last and things that will continue not just for the next 3 to 5 years, not just necessarily for our own lifetimes, but it's become more popular, I think, now to talk about future generations and impacts on them, to think about how they will be inheriting not just the land, but the various tools that we have. And for Meckwell, that's to do with energy generation and making sure that they're going to be around. So I think that's sort of the intent, and certainly something that guides us when we're developing this machinery from an engineering point of view or otherwise.
I think that's absolutely fascinating. I would imagine, it could be quite a challenge to get people thinking in those intergenerational terms in the context of investing in your technology. So, we might think about, our wills and what we bequeath to future generations in terms of maybe big property items like, homes and investment portfolios, if you've got one, that kind of thing, a home if you've got one. But thinking about, vehicles or other, tools, possibly less so. And I think that's a really fascinating concept that you could see buying one of your steam engines as being, that intergenerational investment. Really, really interesting. So it seems to me there's a big resilience, sovereignty, empowerment piece about your technology. You've mentioned the possibility of using it to generate electricity. Could you talk a little bit more about the reality of, if I owned one of these machines, what I might be able to do with it, what that would look like?
Sure. So in terms of the applications of the technology, I guess there's a real range, and we're trying to hit the ones that give the highest utility in some sense, which is a small tractor to begin. And the idea with that is for the appropriate size small holding or horticultural lot, that you can perform the duties that a tractor usually would, but of course using the biomass that's on site and available. So you could imagine any kind of towing. Electricity generation is going to be made available through a generator that's driven by the same engine. We also have, I guess, some plans for the additional features that a tractor might typically have, like a front-end loader and things like this. So we have to be careful to, obviously in the development of the technology, stick to a plan that ensures we can deliver the most important things first, and therefore we're just beginning with the most basic kind of tractor concept. In terms of how people might like to use the electricity they generate or the motion from the tractor, we're really leaving it up to people to decide that for themselves. And again, that's part of energy sovereignty, is that we're just providing the tools to enable them to make the choices about how they generate and use the energy, rather than being too prescriptive about that. But certainly for the time being, those two sort of traction and generation concepts are the big ones.
And people might think, okay, in principle I could imagine that, but in practice, is it really going to be practical to produce biomass on a scale and process it and feed it into this steam engine to actually do work in a way that's somewhat analogous to the support I get at the moment from, let's say, a diesel powered tractor? And I know with the large engine that you've got, there have been some trials actually, using it in businesses around the country. So there are some practical examples of the application of steam power in the 21st century. I'd be interested to hear a bit more about those kind of use cases.
Yeah, that's a good prompt actually, because I did miss earlier the direct application of steam, which is possibly not something that we sort of started out with, but it's become evident there are certain bio-industries that use steam directly, and the one you allude to, Wilding & Co. in Queenstown, we're able to actually, as you say, use the boiler, the test boiler that we have, to help with the steam distillation of essential oils from the pine needles. And so it's finding out about these other areas, which has been quite exciting. And there's possibly a range of things that we still yet to find out the use or the use cases that the technology has. So yeah, in that respect, I think there are probably less limits to it than you might first think, and certainly the input side, talking about how if we can compare it to a diesel tractor or diesel fueled machinery, there will be a certain shift, I suppose, in terms of expectations about how you operate this sort of gear. But in all likelihood, there's no insurmountable challenges. The way that we operate the test boiler is just using chipped wood. It's a very convenient energy source. I think most people have that available. And so even if you don't, you can make it yourself.
So tell us a bit about the fuel requirements. You just mentioned using chipwood in the test rig that you've got at the workshop at the moment. If I had one of these machines on my property, what sorts of materials could I be putting in, and what kind of quantities would I be needing, say, to generate electricity, for example?
Yeah, so for a typical small holding like your own, I think the wood chip is a fairly good way to go. The design brief for the engine was to be able to use the lowest value and most available biomass as fuel, because we don't want to encourage people using useful timber that's valuable for other things as a fuel if it's not necessary. So with respect to that, anything up to 55% moisture content, which is generally what green wood is when a tree is felled, that can be chipped straight into the firebox. However, there's probably lots of other sources of biomass around a property which could also feasibly be used. So exactly how that's utilised, I think, is something to work on. There are options available, for instance, outside of New Zealand, concepts for bio-balers, which can take scrub of various sorts, crop stubbles, things like this, and put them into either bales or pallet form that's sort of more convenient to be used with the Macwell technology. But certainly with the small engines that we're beginning with, there's really no drawback to being able to operate at a level that people can naturally work at. And by that I mean whatever sort of biomass you can gather personally, that can then be used with the engine and in a simple hand-fed manner to run it at its rated output of 26 kilowatts. And in terms of the fuel use, the figure that we throw out there is 2.5 kilograms of biomass per kilowatt hour of energy, whether that's electricity or traction, generated. So that really gives you, I guess, some indication for what you could expect to be using in terms of fuel quantity for a certain job or activity, if you know roughly your power requirement and the length of time that will take.
Thank you. Yeah, I think it's really interesting your observation that this essentially, let's be blunt about it, this isn't a direct plug-in replacement for a diesel-powered tractor. It will require some behaviour change, just as in fact electric vehicles require some kind of behaviour change. And on a personal level, I sometimes find it surprising what a barrier that seems to be, because actually you very quickly get used to plugging your car in your garage in the evening and thinking about longer trips and where you might charge them up and so on. Anyway, that's another conversation. But I'm really interested in the idea that this is a machine that can provide multiple different forms of useful energy for traction, for generating electricity, steam for those purposes, in a way that's kind of entirely off grid. Are there other kind of use cases that are quite that you're aware of? People are thinking, actually this could be useful for us in our particular context.
In terms of the application, I think, well, as I said, there is a range, but what's possibly more interesting is the same applications across different regions. So we're looking at New Zealand as a market, of course, but there's a lot of scope in other countries, particularly developing countries, and I would say there's a number of reasons for that, not least around the size of the equipment we're beginning with, but also when you think about the sort of tropical regions, the availability of biomass and water, which is the two things needed. And so we're building relationships in the Pacific and hoping to do a lot of work there as well. And, beyond that, the scope really grows to sort of a global perspective. But in each case, it's about understanding what energy sovereignty means for them, and to be able to, again, provide the tools, but to make sure that it's going to be meeting their needs. And even if the application seems similar, there's always going to be nuanced differences there. So it's about working with people, and I think it's sort of similar to what you were saying just then about, behaviour change and what's needed there. I guess there's always something at the end of the day that's fairly human about the way that technology needs to be applied, and so that's where, for me, the interesting part is.
Yeah, I had a wonderful conversation a few months ago with Brendan O'Connell, who's the CEO of Agritech New Zealand, and he was very much reflecting on, technology as an enabler, but the requirement for, behaviour change and good decision making by people being absolutely kind of key. So I think there's some really interesting resonance between those two conversations. So what particular challenges are you seeing? So you have this technology, you're seeing a future, and we'll talk a little bit more about that in a moment, where this could become increasingly relevant. But as a business right now, what do you see as your kind of number one challenge?
Well, right now we're an early stage startup, essentially, so funding is always a massive barrier, particularly because what we're designing is a fairly complex system, in the sense that there's a lot of moving parts and it's fairly large. So it's not a consumer good in the sense that a lot of small tech items can be. And so certainly my goal is to ensure that the business can grow in a way that we can deliver these products and deliver on the company's vision and purpose. In terms of the engineering work that's required, there's also hurdles because we are doing something which is not really being done anywhere else. So it's not like we can just go down the road to source steam engine parts from the local supplier. We have to be the supplier, so we make everything from scratch. Everything's designed in the office and produced in the workshop. And obviously that has its benefits, but it's also sometimes a costly way of doing things, and certainly takes time. So those are the things that are always sort of front of mind. Yep.
Yeah. I have to say, though, there is something comforting about being able to see drawing boards and designs and lathes and people with those skills to be able to construct things. It slightly demystifies it compared to just going to a store and buying something as a retail item.
I'm glad you see it that way. It's very satisfying work to be involved with because that tangible aspect is there. And really when we go out and talk to people, the picture can be painted for them, but certainly being able to show them a hard good is invaluable for communicating what we're doing.
And I was reflecting when you were talking about the challenge of funding, and in fact reflecting on much of the conversation we've had so far. Why would anybody want Mackwell to flourish? And one of the things I'm interested in is for businesses, if your only goal is to make money, why would the rest of society really want you to flourish? You have to have a business offering that people see as valuable and making a positive contribution to science. And in my view, what you're trying to do absolutely fulfills that. And so one would hope that in time people would see that and be keen to see you flourish. And that's just, again, reflecting on a previous conversation I've had with a podcast guest. So with that, I just want to spend a minute or two thinking about the future that you see, because right now diesel is super convenient and relatively cheap. It's getting more expensive, and I'm not suggesting that people are not struggling with the cost of living crisis, but in terms of a form of energy, a convenient form of energy, we've got very used to it. We see it as being abundantly available and as I say, relatively affordable. Electricity may be a bit less convenient. Certainly there aren't the big agricultural machines yet, although they're coming, that can be electrified. So what future are you seeing that really provides the context for your technology?
That's a good question. I never liked a crystal ball, but I certainly think that the transition that's happening right now, obviously it's sort of a Brave New World situation in some ways, and there is the forces at play that, you know, determine whether, say, electrification becomes the path for everything, or whether there is a range of possible technologies that we can make use of. So that is to say, some things obviously outside of our control, but I think with the responses we're getting at the moment, there seems to be at least a recognition of the value in something like a technology that can provide many of the functions that we really rely on liquid fossil fuels for at the moment, but to be able to do that with biomass. And certainly, again, in New Zealand, there's been, I think, a history of innovation, but also, you know, having that stem from a desire for self-sufficiency and to be able to do things on our own 2 feet, because we are a small island nation at the bottom of the world. And although globalisation has probably removed a lot of the kind of barriers that introduced those values in the first place, there's possibly a return to that a bit more now that I'm seeing, and just from talking to people, that, yeah, it gives me confidence that this is something that will start to take a more important place in our lives. And at least, you know, as I've said before many times today, to give people the option, I think that's really what it's about, because, yeah, you don't need to necessarily predict the future in order to be able to prepare for it. You can at least give yourself some ways to de-risk the possibilities. And so I think steam is a great option there.
Yeah, I think for me, I find it quite compelling thinking about a future where, yeah, the availability, the cost of liquid fossil fuels could increase, the social acceptability of burning them decreases, international supply chains become more disrupted by whether that's global conflict or energy shortage, and obviously shipping itself uses quite a lot of energy. And so having some kind of plan B up our sleeve seems pretty sensible. And there's something, as I mentioned before, very reassuring about the idea that you could go to your local engineering firm or mechanic down the road and have a sporting chance of getting that valve or piston or whatever repaired using, you know, old school engineering expertise. So, yeah,
I think that's right. And there's also another aspect to that, which is just that the scalability of the technology we're working on at the moment really makes it fit for some of those applications which I haven't talked about yet, but you just mentioned, such as shipping, heavy shipping. You know, it's so energy intensive, but there is, and we've modelled this just to check that it would work. There is a chance, for instance, to convert a container ship, and let's say we begin with one that's moving bulk biomass, so, you know, wood chip export from New Zealand is a thing. You could quite easily power, in theory, this large vessel with the same kind of engine using, say, just 2 or 3% of the export good as a fuel. So, you know, once you start looking at it from that point of view, it's not necessarily about having to eliminate or live in a world where those services don't exist, but being able to actually provide for them in a different way.
Yeah, thank you. So just to finish up on the Macwell part of this conversation, I want to come back to some more personal reflections from you. When might listeners first hear a kind of steam whistle on a farm near them?
Well, if you're anywhere near our workshop in Hereward, then you already hear the whistle. But we're certainly hoping to have the first one out in the field mid next year, and that will be the prototype tractor A35. So yes, we're looking forward to certainly letting people know about that.
And that's the equivalent to a 35 horsepower diesel tractor?
Correct, yeah. So again, part of the design brief was to really make it, in whatever size of equipment we're manufacturing, to make it the same approximate size or footprint as the diesel equivalent. So in this case, it would be, as you say, a diesel tractor, and therefore having the same, essentially same power to weight ratio keeping things similar enough that you don't have to completely change your mode of operation to make use of the technology.
Yeah. Thank you. Well, I look forward to hearing one of these steam whistles, certainly on a farm near me up in Oxford in North Canterbury. And I think its relevance to the future of the food system is pretty clear to me. So thank you for that. So I hinted I was keen to kind of transition to a slightly more kind of personal reflection from you. And as you've said, you have had a long-standing interest in sustainability, and you've made some career choices that reflect that. I was interested in what you might share in your personal life that you're doing that reflects that interest.
Well, I may not be a star model, but I guess there's a couple of things. First is that since moving to Christchurch, my partner and I have gone down to being a one-car household, which is something that I've wanted to do for a long time. And having now achieved it, really realised that if there was any reservation or anything holding that back from happening sooner, it's just the last sort of 1 or 2% of your lifestyle, and you keep clinging to things. So that was a sort of important lesson in other ways as well. So I ride my bicycle now to most places, which Christchurch is really well set up for, which is great. I think outside of that, really just try and keep involved with community projects that are in that vein. So certainly when I was living in Auckland, I was involved with Bike Auckland, that's a sort of cycling advocacy group up there. I was also a part of the Tamaki Estuary Preservation Society, or Protection Society, sorry. And so that was really concerned with the health of the local waterways. And I guess in both of those cases, it's, for me, driven by that desire to increase connection with the immediate environment. And so that really goes back to one of the earlier things I said today, which was just about being able to see and experience things firsthand and having that drive your actions, because there's certainly a lot that can be done, a lot of good that can be done, in the digital world, I suppose, and being able to connect people that way. But there's something about the immediacy of working with the people and the places that you're in, which I think really encourages the right kind of behaviours. And so I engage in that myself as much as possible.
Yeah, thank you for sharing that. Have you got any recommendations for listeners in terms of a book or a podcast or some other resource of that nature that you found useful or inspiring in your life?
Yes, yeah. So there's one, we actually have a copy in the bookshelf at work, but I read it many years ago. It's by a British physicist called David McKay, and it's called Sustainable Energy Without the Hot Air. So it's really quite a good introductory book to climate change and technology, but as much as possible, and this is explained much better at the start of the book, but without the political influences as much as that's possible, just looking at it from the facts and laying out the different options so that people can see really, according to the figures, what sort of things make the most impact, and I guess some of the science behind that in ways that are fairly easy to understand. So I definitely recommend that book. In an effort to increase its availability, David McKay actually publishes a PDF version on his website, so anyone can go in and read that, and you can purchase a hard copy if you'd like to.
So that was Sustainable Energy by David McKay?
Correct.
Yeah, thank you. Excellent. If listeners wanted to take some positive action in relation to sustainability in their own lives, what would your recommendation, your call to action for them be?
I guess in relation to the food system, because that's really what we're talking about today, growing your own is the important one, and it's the message that we really present at Macwell for energy, and that's including food in this case. So to be able to grow your own, I think, is the key thing, and it again is hard to imagine sometimes in our world today, where we pop along to the supermarket and source our food that way. But if you're able to grow your own, or at least to help others who are able to do that, then you not only reduce the carbon footprint in very obvious terms associated with your food collection or consumption, but I think you increase your awareness of what it means to be a responsible consumer. And the way that I feel about it at the moment is that it's quite easy to be reckless with energy or food consumption. So when you have to produce it yourself and you realise the effort that's required, then you start to appreciate a little more what actually goes into those systems, and that will just naturally inform your decisions around how you make use of it. So I think that's a really important message, but something that people have to try themselves to see the value in it.
And I think that's a nice balance to your kind of earlier reference to food as fuel, which, I mean, it literally, obviously, of course, metabolically speaking is, but there'll be many listeners to this podcast who will be, I would imagine, shrieking at whatever device they're listening to this on, saying, food is so much more than that. It's a cultural connector. It's something we identify with on all sorts of levels. And I think what you've just described is one way of perhaps helping people when that's needed to reconnect with it. So, thank you for that. Finally, if you had a superpower to make the world a more sustainable place, to guarantee the prosperity of future generations, what would that be?
Well, I don't know that it's a superpower, but if there was a change I could make, I certainly think within New Zealand, a big one has to be around maybe a combination of, our sort of urban planning and the policy behind that, and I guess from the private sector side of that same coin, investment, and moving away from the sort of obsession we have around property, because it's really taking a lot of possible investment away from emerging technologies and the things which New Zealanders, I think, like to imagine we're at the forefront of. But the reality is that there's, a much larger part of our GDP just going into things like housing stock, and as a result, the kind of urban planning decisions that are made. So if we could change that to have something that perhaps, reflects on what I was saying before in terms of being able to grow your own food, maybe that looks more like the sort of market gardens that you once would have seen in places that make sense but are also convenient for communities to access, and then equally to be able to have the capital available to businesses who are wanting to introduce these technologies that will make a big impact on the things that matter, rather than having it lie dormant, so to speak, in bricks and mortar.
I have to say, it certainly seems to me to be or to require a superpower to be able to redirect those flows of capital to initiatives that will help create that prosperous future for the coming generations. So I wouldn't for one moment suggest that isn't superpower territory. So thank you again for sharing that. It's been a fascinating discussion. Sharing some thoughts about sustainability with an engineer, somebody with your depth of understanding of the energy system and your interest in providing communities and individuals with a plan B or a plan C for providing energy for themselves, that energy sovereignty piece. So thank you very much for that.
Thank you, Roger.
Have you given me a cause for hope? Well, of course you have. The plan B or C for energy, absolutely. Have you offered a call to action? I think there have been a number of different calls to action, and possibly for me, the one that comes through most loudly from this conversation is for people to think differently about energy and to be prepared to behave differently in relation to it. So, and that's something I'm sure we will unpack more in future episodes. So for listeners out there, thank you very much for listening to this episode of my podcast series. I very much hope you've enjoyed it. If you're interested in more of these conversations about people, planet and food, Please subscribe to Sigest and rate and review the show, and share with anybody else who you think might be interested in this series and these conversations. If you've got any questions or suggestions for people you think I should have a chat with on these topics, then please do get in touch with me via sigest@plantandfood.co.nz. Thank you again for listening. Look forward to recording the next episode of this, and in the meantime, Martiwa, see you soon.